Well, that was a great overview of SDSC's history, but now it's time to hear from the man himself. I'd like to offer a warm welcome to Dr. Mike Norman, the director of the San Diego Supercomputer Center and member of UCSD's physics faculty, to tell us a bit about what's been happening at SDSC recently and to celebrate its 35th anniversary. So I'm going to turn it over to you, Mike.
Thank you, Sean. Well, it's really a pleasure to be here today in SDSC's virtual booth at SC20. Before I get into my remarks, I'd like to thank SDSC's external relations team, who has done a fantastic job planning this, organizing it, and executing it. You make us all look very good. Thank you. Let me share my slides. Okay. Well, this kicks off 3 days of presentations in this time slot. And be sure to bookmark this URL here, sc20.sdsc.edu. This website contains a variety of information about not only the presentations, but also how you can get a free coffee mug or an Expanse t-shirt. So today we are here to celebrate SDSC's 35th anniversary. And like our 30th anniversary, when we dedicated our Comet supercomputer, we're proud to announce that our new Expanse supercomputer enters production any day now. So we're here to officially dedicate this all-new system and highlight some of its recent events, now part of the interactive timeline. At this same time tomorrow, we'll share more details about the new supercomputer and why we think it's so cool, why we have given it the tagline, Computing Without Boundaries, to describe its capabilities. But for now, I'd like to just tell you that Expanse, thanks to a grant from the National Science Foundation and with the support of our vendor partners, which include Dell, NVIDIA, and AMD, has more than twice the performance of our extremely popular Comet supercomputer, which has been widely used in academia and industry. Like Comet, Expanse will be part of the NSF's Extreme Science and Engineering Discovery Environment, or EXCEED, which allocates resources to academic researchers on such systems. Please return tomorrow at this time to hear more details about the Expanse system, which I'm extremely excited about. And then on Thursday, again at this same time, we'll be presenting CloudBank to you. CloudBank is the result of a 5-year NSF grant to stand up a new kind of entity that they call a cloud access entity, which simplifies the access to the public clouds for researchers in computer science. It is a pilot project, but it has great potential to expand beyond computer science research to the broader set of funded activities at the National Science Foundation. The CloudBank portal went into production this summer, so we are actually up and running and working with our very first users. I'm proud to tell you that this year, as in years in the past, SDSC has been recognized with 2 HPC Wire Awards. These are Editors Awards for Best Use of HPC in the Cloud and for Best Use of HPC in Energy. In the first case, HPC in the cloud, researchers from the IceCube Neutrino Observatory, SDSC, and the Open Science Grid and other collaborators leveraged 51,000 GPUs in the cloud from all three major cloud providers in all regions of the world. Basically, every GPU that was available was subscribed for a 2-hour computation of IceCube data analysis. They call this a cloud burst, and it was announced this time last year at SC19 and generated a lot of interest. I'd like to recognize the investigators, Frank Werthwein and Igor Svilagoy from SDSC, Benedict Riedel and David Schultz at the IceCube Neutrino Observatory at the University of Wisconsin-Madison, and the HT Condor Internet 2 and Pacific Research Platform teams, who all contributed to this technical achievement. SDSC was also recognized for best use of HPC in energy, that is, energy production. Researchers from Georgia Tech and the Hanoi University of Science and Technology in Vietnam used our Comet supercomputer as well as TAC's Stampede 2 system to identify 4 lead-free candidates for a more efficient, cheaper alternative to the silicon used in solar panels. So congratulations to Huan Tran at the Georgia Institute of Technology and Vu Tuoc at the Hanoi University. So turning now to today's celebration, SDSC's 35th anniversary. When SDSC launched its first supercomputer in 1985, a Cray XMP 48, which I used, it was about as powerful as an iPhone is today. 30 years later, in 2015, when we launched Comet, this was a machine some 2 million times as powerful than the first system, and thousands more users, I might add. Now, just 5 years later, Expanse is twice again as powerful as Comet, while taking up a smaller footprint in our data center. Kind of remarkable. Today, SDSC continues to serve the national and even global research community, as well as research at the local and state levels. And to celebrate our history, SDSC has created a interactive timeline of our entire 35-year history. So I'm going to stop sharing this and share the timeline and just comment on a few key events in the last 5 years. So this timeline is linked to the sc20.sdsc.edu page. It can also be found from our regular homepage. And one simply scrolls down to see significant events from our 35-year history. Now, this is arranged in reverse order. It's kind of like looking out into space. You look back into time, and the things that are closest to us are closest to the current epoch. And so, as I've said, we're dedicating Expanse today, and we'll be talking about it in more detail tomorrow. Another thing that we do here at SDSC is create science gateways. And here's an item about a new science gateway called XIMG, which stands for the X-ray imaging of microstructures. It will serve up materials information based on X-ray diffraction studies for the community of researchers working on new materials. up to speed on my notes here. Thursday, we'll be telling you more about Cloud Bank. This summer, the NSF gave us another award for an HPC system. This one, a experimental platform for AI research called Voyager. This will be deployed sometime next summer, and it's a secret project. We cannot tell you about the technology inside of it, but it's going to be cutting edge, and it's going to give AI researchers a new toy to play with. So stay tuned for that. Here is an item about the 51,000 GPU cloudburst experiment that I mentioned. This shows the ramp up and the ramp down of the utilization of GPUs on every cloud platform in every region of the world. And I believe this team has done it again for Supercomputing 20, and you should be staying tuned for that. In 2019, the NSF selected SDSC to lead the Cloud Bank, the EarthCube office. This is the coordinating office that manages the development of advanced cyber infrastructure for the geosciences. I mentioned our support of the Neutrino Observatory in the South Pole called IceCube through the Cloudburst project, but it also highlights our longstanding integration with the Open Science Grid, where in this case, this was the detection of the energetic neutrinos that coincided with the first neutron star merger observed through the gravity wave experiment. And so this opened up the era of multi-messenger astrophysics. So you can see there's a lot here to look at. And this is just the last 5 years since our 30th anniversary. If you want to dig deeper into our history, you simply keep pressing the down button and you can go all the way back to the beginning, November 14th, 1985, which is almost exactly 35 years ago. So I'm going to stop sharing this and share my screen, my PowerPoint again. So to conclude, I would like to urge you to visit that website, sc20.sdsc.edu, and click on events, and this will give you more information about the upcoming events. There is one that I have not mentioned yet, which should be of interest to many of you. As you will learn tomorrow, our new Expanse supercomputer features the latest AMD microprocessors. And in partnership with AMD, we have created an AMD Hpc User Forum. And this event, which is 8 a.m. Pacific, 11 a.m. Eastern, will bring together folks from SDSC and executives from AMD to talk about this new user forum and what we hope to accomplish together. So in summary, thank you all for coming to SDSC's virtual booth. Thank you for your interest in our 35 years of innovation, and please come back tomorrow and Thursday to hear about what that looks like today. Thank you very much, and I'm happy to now take questions.
Mike, thank you. Thank you for that overview. As your moderator here, I guess I'll as we monitor the Q&A here, I'm going to throw you some questions to ponder and give us some perspective. You know, you're a researcher yourself, and as you said, you've been using these systems going back to the beginning of SDSC. So you've got the long view, which made me think of the question I want to ask, which is tied into the long tail and scientific impact. I mean, some of the examples you've shown are quite amazing in terms of the impact that the systems at SDSC have delivered. They're certainly not the largest systems, but they are making a substantial impact in science. And I'd like your thoughts on how are these relatively modest-sized systems able to do that? What is the secret sauce that puts SDSC at the forefront of science, if not the largest systems?
Yeah, that's a great question. Well, this notion of long tail has been around for a while. It refers to the fact that if you plot job size versus number, it looks like this exponential tail. And long tail refers to the small jobs that are very numerous at the end of that distribution function. And so we did an analysis back in 2012 where we analyzed all of Exceed's workload. At the time, it was called TeraGrid, but the workload across the entire TeraGrid in terms of job size, core count, and number. And we discovered that 98% of all jobs were less than 2,000 cores, and 60% of the total consumption of resource was in that long tail. And so we designed a pilot system called Trestles to see if we could actually serve that community efficiently. And we put in place architectural elements in that system. We put in management policies and operational policies. And it was an enormous success. And that led us to go bigger with Comet, which is our long tail system. And now with Expanse, the tail not only gets longer, but the size of the largest jobs that we can handle is also getting larger. For example, on Expanse, it will be 4,000 cores. And so, but the key to long tail is leaving enough headroom in the system so that small jobs can get through quickly. And that's something that we have done now since Trestles and done very successfully. I'll just mention one bragging point, which is for the Comet project. Our goal for the entire 5-year project was to surpass 10,000 unique users. And we surpassed that in the first year. We are now in year 5 of the Comet project, and we have served more than 80,000 unique users. And part of that magic is also the use of gateways as the means of access to the system. And so keeping headroom, putting in place management and scheduling policies that recognize the importance of small jobs and architecting a system that can be scaled out. That's how we've been able to do it. Thanks for that question.
Thank you, Mike. I'd like to toss another one at you. You were instrumental in the Gordon system, seems like many years ago. And Gordon was full of innovation. You know, I think many of the systems since then and before then, likewise, had many new innovations. So can you comment on your sort of philosophy about balancing new technology and new innovation with the simultaneous need to support these long tail users? How do you see those two intersecting, and how does SDSC respond to that kind of a challenge, or maybe it's even a tension at times?
Yeah, it's really a trick to skate to where the puck is going to be. You write a proposal 2 years before you deploy, and you've got to imagine not only what technology will be available then, but also what the users are going to want then. Now, the user community doesn't evolve as rapidly as the hardware. And so you can look at what your current users do. And our strategy has always been to build a system that will be great for current users, but also add a new innovative element. Each time we deploy a system, add a new innovative element, or maybe two, that will provide opportunities for new kinds of usage. And with Gordon back in 2011, it was recognizing that computing was becoming more data intensive, and so you just needed more storage in the memory hierarchy. And so we put flash SSD on a HPC system for the first time in the nation. Actually, that's not quite true. The craze in the 1980s had flash, but hardly anyone remembers that. I remember that because I was computing on that system. But so storage in the right place, and that continues to be an important part of innovation. Ever since Gordon, we have put flash on node, and that amount has just grown and grown, such that now with Expanse, there'll be more than 1 terabyte of flash per node, which is really helpful for AI workloads. The other thing that we did right, kind of got lucky, is on Comet, we put virtualization on the system. And this was in advance of this huge development in containerized software, which eases the deployment of a variety of bioinformatic and machine learning workflows. And so we got lucky there. We anticipated this transition to virtualized computing. And as you'll hear tomorrow about Expanse, we do all of that. Everything I just talked about is on Expanse. And then we add a couple of new goodies, which is the ability to do distributed heterogeneous workflows from edge to data center through composable systems. And we also, for the first time, are offering cloud integration, cloud bursting, to provide yet more flexibility to the user. And so it's a matter of seeing where the technology trends are going and anticipating what the researchers are going to want to do.
Terrific. We have a couple questions that have come in, Mike, in the last couple of minutes here. Let me get to the first one of these. How do you see the commercial cloud fitting into the HPC landscape in the coming years?
I think of it as a kind of offload capacity system for on-prem HPC resources. That's certainly how we think about it from the standpoint of Expanse. These systems have a 5-year life, but in 5 years, the cloud will deploy lots of new instance types. And so, for example, just to make it very concrete, Expanse has NVIDIA V100s, but it will not have NVIDIA A100s, which are cool. We can create a virtual partition in the cloud of A100 GPUs. Now, you have to bring your money. It's not free to compute in the cloud. We are doing the plumbing. We're going to make it easy for you to spend your money in the cloud from Expanse. So I think that's one answer. The other answer, and this really gets to the Cloud Bank project, which is fully cloud native, is that data science is a very good match to cloud computing resources. The ability to put large amounts of data and spin up databases and so forth. And so this is why Cloud Bank is starting with the computer science research and education community, because those folks, by and large, have chosen the cloud as their preferred platform. And we're simply trying to make it a little less painful to use that.
Well, that leads to another question that came in literally just as you were speaking. I imagine it must have tickled somebody's thought process here about the AI as a part of the workload that would happen in the cloud. You mentioned computer science. Do you see AI as being part of that workload that we might look to the cloud to support?
Oh, absolutely, but not just the cloud. We're going to be supporting AI on Expanse. That's why we put all those great GPUs in there. But our Voyager system next summer, which is really an experimental platform that will feature brand new technology under the hood. You know, I have to tell you, I have just started doing deep learning myself in my astrophysics research. And I'll tell you, the hardest part about all that is just wrangling the data in and out of the processors. And boy, you need an HPC system to do that. And so I think data orchestration is really where it's at. I think that the problem with the cloud is there's no one there to help you. Whereas a center like SDSC, there's people to help you. So I'm going to be doing my machine learning on Expanse because there's people to help me.
Well, that's a great lead into another question that came in. One of the keys to meeting the needs of the long tail is to, and I'm reading the question verbatim here, one of the keys to meeting the needs of the long tail is to ensure that you have the staff expertise across a different set of academic disciplines than those that dominate traditional HPC. How have you diversified your team, and what challenges have you faced in doing that, if any? So it's a great question about the staffing, how you staff up differently, or do you, if you're looking at supporting the long tail?
Oh, absolutely. Yeah, you have to balance, you have to match what you're doing on the floor with your staff expertise. So for example, when we deployed Gordon as the first data intensive HPC system in 2012, we hired some data scientists into our advanced applications team. And fast forward to today, I'm telling my team, my leadership, including this guy whose face is on the screen, to hire people with deep learning expertise. And so, yes, you absolutely have to co-evolve your expertise with your scientific focus areas. Now, is it difficult? I'm sorry, someone is running a leaf blower outside my window. I hope you can't hear that. Actually, it's not difficult if you're in a university, because students want to do machine learning and they're graduating all the time. And so the trick is to just entice some of them to come take staff positions.
Well, I think there's an AMD HPC User Forum coming up this week, I think, that folks can register for, and the team here at SDSC has been part of that. Maybe comment on the role that the relationships with vendors play in building those kinds of competencies that maybe the staff don't have. I mean, when you're bringing on a new technology, you don't instantly possess everything you need to know. And these partnerships, whether they're with vendors or programs like Exceed, can kind of supercharge that. How do you see that playing a role?
It plays a very important role because the vendors, of course, are directly in contact with researchers all over the world. And they know exactly where people are going with their research and what they're trying to do with those systems. And so one of the delightful things about this new AMD HPC User Forum is that, well, first of all, we all know, if we've been in HPC for a while, that AMD isn't brand new. They owned the 2000s on the HPC platforms. And so they have deep expertise, and they're connected all over the world. And so this new HPC User Forum is just bringing together folks that are deploying the new technology, the EPYC, Rome processors, and soon the Milan processors, and also the AMD GPUs, which are really cool and powerful. And so they have a reach and, of course, in-house technical experts that are there to help customers. And so SDSC is a customer, and it's getting a lot of attention from AMD. And so that's a way of bringing more expertise. But the main thing about a forum is it is a sharing society. It's everybody who's deploying these AMD systems, all the sites, Purdue, Indiana, Pittsburgh, they all want to get in a room, a virtual room, and share what they know and what they're experiencing with these new systems. And so, it's a way of crowdsourcing knowledge and user support.
Terrific. It was sprinkled throughout your comments and in the opening video as well, and that is on matters of societal importance. And certainly, the Wi-Fi project from Dr. Altintas and other projects in COVID-19 research. Can you maybe just wax poetic for a little bit about those bigger questions that are facing us and how SDSC is able to help researchers tackle those?
Yeah, thanks. Our tagline is, science and society. And so you're asking about the society dimension of what we do. Shortly after the COVID-19 outbreak, there was a tremendous need for HPC resources coming from, frontline researchers. And, those requests came directly to me and to other center directors, but it didn't take very long before Exceed organized a broader engagement across all HPC providers, both NSF as well as DOE. And that was called the COVID-19 HPC Forum or Consortium. And so, it's a case of a capability meeting an opportunity to make a contribution to society. And by now, I think this consortium has delivered probably 1 billion core hours across a dozen sites to 50 or 60 projects, looking at various aspects of the protein, the virus, and drug response. The other topic you mentioned, the wildfire management. Wi-Fi is the project. Wildfire management is the goal. And this is, of course, a societal emergency that we're seeing more and more in the West. But at the technical level, the way it's done is through distributed, composable, data-intensive computing. And so the composable systems capability that we're offering on Expanse is really offering access to that team of experts that created Wi-Fi and saying, do you have an application that looks like this? If so, we'll help you build it and run it from edge to data center. And so I think as we look around, we just see more and more, societal needs, hurricanes, floods, wildfires. We just kind of waiting for the locusts and the plague. So it's, there's no end of a need for quick response and, societal concerns.
Well, I think this year there's a special Gordon Bell category for COVID-19 research, and if I'm not mistaken, Romy Amaro is the lead author on a paper that includes many, including Mahidar Tataneni here from the center. So I think those presentations happen later this week. So if you haven't checked out that new category, that would give you a very good the attendees here. Go take a look at those paper presentations later this week. I just wanted to make a comment. I'm looking at, we have quite a few participants here. If this had been a SC booth talk, we'd be fighting over some mega vendor megaphone here next to us and trying to scare up a few people to the presentation here. So I'm thrilled to report that this venue is giving a much bigger opportunity for folks to participate in something they may not have been able to previously. So I'm really glad to see that. So I don't know if we have any more questions here. I'm looking at the Q&A. I'm not seeing anything in here, but I guess maybe, well, it's possibly one has come in here. Did I miss it? Here we go. Let me get to this one before I ask what I was just going to ask. This is another cloud one here, Mike. Do you see your center or other supercomputer centers moving fully to the cloud in the future? Or do you see an expanse of the current hybrid cloud infrastructure that many centers are adopting? So how do you see, what's the trajectory here of, traditional on-prem supercomputer centers vis-a-vis the cloud? And is there some shifting balance there?
It's going to shift, but I predict it's going to take at least 10 years to shift substantially away from, on-prem or on-prem. And the reason for that is it's not the hardware, it's the people. And the people, are organized around centers or, labs. And the infrastructure as a service is an incomplete offering. If software as a service is getting more usable, but what you really need is scientific facilitation as a service. And that's very expensive to scale, because fundamentally, the scaling parameter is the human being. And so I think, when I think about the future of Cloud Bank, our technical implementation scales unbelievably, but the bottleneck is the humans who will facilitate the use of the cloud. And so what you will need in the future is a center filled with experts that know how to translate your research needs into cloud implementations. And that's certainly, we're just sticking a toe in the water with Cloud Bank. But if we're to live in a future where, it's all being done in the cloud, you still need the buildings filled with those technical cyber infrastructure experts to facilitate that use.
That is a really important point, Mike. I'm glad you made that. You mentioned the cloud integration with Expanse. Our first demonstration of that is the Cypress Science Gateway, and I can tell you, knowing what the folks on the ground have done to make that happen, there's a lot of heavy lift. It's not just, there's some resource in the cloud, and the team has addressed everything from security and networking and data movement and portability of the application. So I think you're dead on with respect to the amount of work that's actually going to be required, and it's going to have to be done on an application by application basis, I think, to understand, where the bottlenecks are and the resource constraints. So, I guess I see just some nice comments in the chat here, Mike, about folks who have, very happy to see this trajectory of SDSC and see the bright future it has ahead. And I just maybe was going to ask you if you wanted to kind of ponder the future a little bit, for this computing without boundaries theme that you have with Expanse, and maybe paint that across SDSC writ large. What's this 5 to 10 year horizon look like for centers like SDSC and impact of the scientific research enterprise?
Well, our prime sponsor at the National Science Foundation talks about a integrated national cyber infrastructure. And what that means is everything connected together so that you can work, on distributed resources. And that is certainly a vision that we've had at SDSC for quite some time now. We implement that vision. And Expanse, I would say, is our best current notion of what that needs to look like. And so I think, the issue of the public cloud, from the standpoint of the director of a supercomputer center, the cloud looks different in 3 ways. One is the resource catalog is far more diverse than what we offer on-prem. The second is there's real money involved. Money changes hands when you compute in the cloud. And so it's like a taxi. You get into a taxi or an Uber and, it costs money to go from A to B. And so facilitating that money flow is a job for a bank-like entity, which is why we call Cloud Bank Cloud Bank. It's not a bunch of clouds on the horizon, it's a bank like Chase. And then the third is this user support issue. With such diverse resources to support and new kinds of scientific computing activities that people want to do, the user support becomes the rate limiting factor. And so, and yet this is something that no one wants to pay for. I think Exceed is amazing in that it recognized the importance of the human capital in getting science done. And so you should think about an Exceed level national investment in order to facilitate the use of the cloud. But I will tell you, not everyone wants to use the cloud. It's far more comfortable to use, an Exceed resource because we've made it that way. It's taken 20 years to get this right, but it's actually very usable. And so I think it's just going to be a gradual enlargement of the integrated distributed cyber infrastructure. And there'll be some stuff done in the cloud and some stuff done on-prem. And in a way, every research project is a bespoke instance of pulling that stuff together and making it work for the researcher. And so I think my prediction is there will be more usage, scientific usage of the cloud, but right now it's minuscule. And the reason why it's minuscule is it's not that easy to use, or people don't know how to use it.
You talked about distributed cyber infrastructure. I know SDSC and its partners have done a lot of work in high performance distributed networking as well. Maybe comment on the role of projects like PRP and others in facilitating that distributed computing.
Well, yeah, we've done a lot of that in partnership with Cal IT2, Qualcomm Institute. Of course, the Open Science Grid is natively distributed, and you know, we started working with the Open Science Grid when Gordon arrived in 2012, and we did our first pilot probably in 2013. And so the thing is, if you're focused on long tail, OSG is the long tail, and that's why I was so keen on you know, achieving a real integration with them. And of course, that effort is led by Frank Werthwein, the executive director of the Open Science Grid, who's a physics department colleague of mine. And so that's how that came to pass. But you know, I think the Large Hadron Collider, in a way, was the first distributed computing mandate that the world had, and they figured out a solution. And now that you have, you know, edge devices, now distributed computing can be everybody's bailiwick. But how to make that easy to use? And fortunately, along comes Kubernetes, and which will run on Expanse and federate with remote resources. There's a way to do that. You know, where did that come from? It came from Google. It came from the cloud. So I guess that's the other thing I would say is, you know, the hardware and software evolution in the cloud is rapid, but we can get it and we can deploy it on-prem, and we do that. And so that way, integration becomes easier between on-prem and the cloud.
Well, thank you for that, Mike. We just have a few minutes left, and I just wanted to say, you know, congratulations on 35 years. Your shepherding of the center through its most recent 10 plus years, and thank you for the articulation of how all of these pieces fit together. I think between the people, the systems, and the whole ecosystem, you know, I think the community is grateful for the role you've played in making that a reality at SDSC. And I'm sure everybody is looking forward to 5 great years of Expanse and the work it's going to help carry out. So we're just wrapping up here. So any parting thoughts, Mike, before we sign off here?
Well, it's been fantastic. I've loved it. Every twist and turn has been a learning experience. Please come to our virtual booth tomorrow and Thursday to hear more about Expanse and Cloud Bank. And if you're interested in AMD technology, please come to the user forum Thursday morning. Thank you very much.
Thank you, Mike, and thanks for all the attendees and the great questions. It's great to see the big turnout here. Like Mike said, we've got more great programming coming up throughout SC, both here in our virtual booth as well as some of the talks. And our terrific ER department has many articles about these impacts, and please check those out as well on our website. And very much appreciate you tuning in here. Thanks so much, and enjoy the rest of supercomputing.
Thank you. Bye-bye.